right, ladies and gentlemen, good afternoon. Welcome back from Thanksgiving break. I hope it was awesome. Today we're going to talk a little bit about the lesson we started today and the implications of the lesson that we were looking at. So if you look at a circuit, there are two types of circuits, a series circuit and a parallel circuit, okay? You created a very simple circuit. It only had one connection. But as we talked about, you had to make sure you had a complete solid line from beginning to end, or you would have a break in your connection, and as a result, would not be able to form a complete circuit. So tomorrow, you're actually going to be able to test your circuits to see how well they work. So let's talk about the difference between a series circuit and a parallel circuit. In a series circuit, you have your battery here, and these are all the resistors. Okay, so let's say, for example, you had 3 circuits, okay? For example, maybe 3 light bulbs, okay? A much smaller example, let's say, of what you would have in a Christmas tree, okay? So what would happen here is if a light bulb would break, it doesn't matter which light bulb, but let's just say the center one. The entire string of lights would go out. Okay, this was very common in the old Christmas lights in the 70s and 80s. Okay, and the reason for that is because now, since this light doesn't work, the circuit is broken and power cannot completely flow through, so it doesn't connect from the beginning to the end of the battery. And as a result, or the power source, and as a result, there is no power at all. But if we look here, we have a parallel circuit. So where here you have power flow that simply goes this way, a parallel circuit is a little bit different. You can have power flow that goes this way. You can have power flow that goes this way. Oh, my marker's dry. That goes this way. Power flow that goes this way. And of course, the ever obvious power flow that goes all the way around. So what does this mean? Well, if we have our bulbs, let's say here, 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 and here, and let's say this bulb goes out, well, this bulb will still connect this way, this bulb will still connect this way, and this bulb will still connect this way. So the only bulb that will not turn on will be the one that's broken. Okay, it made it a lot easier for those of us buying Christmas lights because it allows us to identify and replace a broken bulb, as opposed to when they used to be in a series circuit where the entire string would go out and we would have to try to hunt and figure out which light was broken. So what you did is in your circuit board, so you had a copper circuit board, okay? It was more rectangular, but you had to create a drawing in ink of any kind. Okay, my circuit board looks like this. Okay, so what I did was I connected, again, you saw that there was a complete flow from point A to point B. Okay, so now your boards are all sitting in the etching solution, so I'm looking forward to seeing what they look like tomorrow when they come out of the etching solution. And all of the copper that was not protected by the ink design that you made would be removed, and the copper that is under the ink design would be protected and therefore would stay behind. So Once you get your board, you're actually going to connect them to a battery, and you're going to see what kind of power you produce, okay? Well, one of the reasons why this is important, and this is something you've been focusing on in the past, but you focused on in the past, but now we're going to address with a specific substance, is waste production. Now, we use circuit boards for many, many, many things. We use them in our phones, we use them in our computers, we use them in our televisions, okay? And let's face it, we have many electronic devices. Gaming systems, they all have some kind of a circuit board, okay? So when you're using, you're creating these circuit boards, you're actually using etching solution, which produces waste. But the copper that's required to be in these circuit boards, it actually has to be mined. So from the mining process in the very, very, very beginning to the production of the circuit boards, there is a great deal of waste that's being produced. It's actually shown that the majority of waste that is produced in the manufacturing industry is actually copper, okay? So copper, although you do have to have some copper in your diet, too much copper is actually bad for you. If you put too much copper in your diet, you will suffer from nausea, vomiting, diarrhea, abdominal pain. If you inhale it, it'll give you dizziness, again, nausea, vomiting, so on and so forth. So exposure to too much copper is bad. So all that copper waste that is being produced cannot go into the waste disposal system. So we cannot have it go into our water supply. It cannot be dumped down the sinks. It actually has to be dealt with appropriately. So we will look at how it is diluted prior to any kind of disposals and how the copper is treated in later sections. But for now, the purpose of looking at it is to see exactly what is done to create a circuit board. Yes, yours was very, very simple, but you'll see how much copper chloride was actually used. And by the same token, to think about how much copper is removed and how much etching solution has to be used in order for you to be able to actually produce a circuit board. Okay, so I hope this video helped a little bit with what we were doing. We'll continue with part 2 tomorrow, which will actually show what it is that we've done and show how the power managed to go through the circuit boards. And I look forward to seeing you then.